Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Rolf Klingberg, your host. Today I have the more detailed video of the last round of testing that we did at Mirage, which was quite a while ago. It has taken me a while to get around to completing it, and I'm sorry for the delay. But I think we got some interesting stuff to show you today. We're going to have, there was one flight and a couple of taxi tests. I'm going to show you the one flight that I had, and I'm going to run like 4 views of it, different angles, different things to look at. Then I'll have a voiceover describing everything that's going on. And then I'm going to have a segment on the control stick and mixer and what went wrong with that caused the control problems during the flight, which caused me to terminate the flight early. Nothing broke though, that's the important part. And I'm going to have a segment of a quick tip. Something that you might be able to use in your own constructions or modifications of your own aircraft, a way to quickly and securely connect control cables. It seems that recently I've slipped into what they call long COVID, and that is extremely limiting on my physical capabilities and mental capabilities. And you might pick up some of those during this video because my ability to find words and use them has dropped off, and I'll try to edit out most of them, but you'll probably see some. I'm not going to go into great detail to it here. It's nothing to worry about too much because it's not like people are dropping over left and right from it, but it can be disabling. And right now I am incapacitated enough that I have about 2 hours worth, 2-hour window per day to do work, physical work, and that's quite limiting, and I can't travel. Travel would be extremely difficult, and so I have to stay home, and that doesn't allow me to go out and test fly or do any of that. So the project right now is going to be different. I'm going to be doing research on the aerodynamics of stall spin, because I think there's some interesting work to be done there. I'm going to do that all by computer analysis. And I have some interesting ideas about portable ultralight aircraft and how to get higher performance while still keeping them transportable. And I might actually build some samples and so forth to do a little research in that area. But overall, this project is going to be on hold. And I think the most likely, from what I've read, the most likely time frame is 6 to 12 months, up to a year. So in the meantime, I'm going to be turning off the billing for all of my patrons, and I'm going to I'll make a comment here. If you are a member on my YouTube channel, now might be the time to drop that membership because there's nothing that really needs funding, nothing I need help with financially, and you're not going to get any more videos past this one for quite some time, so you might want to drop that membership. So there we go. Still here, and I know I look perfectly normal, and when I walk around I see almost normal, but there's quite a few handicaps that go with this. So no pity though. This is just life. It happens to some people, and I'm working through it as best I can, and trying to get off to some clinical trials and what have you. Okay, I thought I'd have just a little commentary on the front of this video to orient you with what you're watching. I'm sitting in the glider on the dry lake bed at Mirage, and I'm pointed generally north, and our plan is to tow me up to between 50 and 100 feet. I'm going to fly straight for a good distance, and then release and turn right and turn left and do a nice landing, which is an excellent plan if you can actually follow it. But there was some slack in the control cables and some other slop in the control system, causing me to have inaccurate control over the glider. So I ended the flight prematurely. We're actually in the ultralight alcove, and if you go to Google Maps and zoom in on the west side of the lake bed and scroll north, you'll eventually see a little area that jogs to the left, and that's the ultralight alcove. So that said, here we go.
Picking up slack. Stopped.
Ready, Peter. Controls are free. Okay, go 35.
Going 35.
Flaps out, he's rolling. Looks like he's doing okay. Faster. He's off the ground. He's up. The rope broke. We were supposed to go to the left, but he's out of the way.
So I'll stop the video here and get racked up to look at the video again to do some analysis. In some spots I'll put it in slow motion and point out things that you might want to observe. Overall though, it was a great flight. That said, let's get on with the more interesting stuff and talk about the glider.
Stop.
Stopped.
Ready, Peter. Controls are free. Okay, go 35.
Going 35.
Flaps out, he's rolling. Looks like he's doing okay.
As you can see, there's quite a bit of dust coming up behind the tow truck, and that's emblematic of Mirage dry lake bed. And I didn't care for it very much. I have a face shield on, but dust is still coming in there, getting in my contacts, causing all kinds of problems. I only have about 250-foot roll before I'm in the dust from the truck, because that's the length of the tow rope. And we decided to do the takeoff rolls really slow. Obviously I could take off in way less than 250 feet, but we're doing it slow so I have a chance to test the controls before I try to lift it off the ground. We're not absolutely certain how well the glider is trimmed at this point, so we thought, you know, nice long roll, and the less acceleration is easier for me to deal with, but problematic in terms of the dust. And especially when I lift off, I have no horizon to judge whether I'm wings level or not, so I'm having to just fly by feel. And the amount of density that you're seeing in the dust is the same that I'm seeing from my end, obviously. We're going to look at some video that's shot from the glider, and you won't see that dust at all. It's quite amazing. But when you're looking fore and aft along the tow rope, you can't see what's ahead of you.
He's off the ground. He's up.
At this point, I've climbed up and over to the left to get out of the dust, and I wanted to get wings level flight, and then continue my climb up to higher altitude to be well above the dust. And if you look closely here, you'll see that both elevons are in the down position, and so I'm trying to stop the climb that I had for getting out of the dust and just hold level right there. And that's when more of the problems start. When I was coming up out of the dust, I'd climb a little and it'd climb too fast, and try to put the nose back down. Then I had to put even more elevator in to get the nose down. at least I thought on the stick, because the slop that's in the stick, I had a rough ride getting up out of the dust, not turbulence kind of rough, but just not flying smoothly. Nominally, we apply pressure to the stick to maneuver aircraft, but I was having to actually actively move the stick fore and aft, which was indicative of the slop that was in the system. And actually, you're looking at elevons that are probably half or 3/4 down to the limit, which is a lot of elevator. So I had overshot on the climb side, which you really can't see. From this angle, you can't see when it has elevons up, but you can certainly see the down elevons here. So I'm trying to get it stabilized. Right at this point, I'm putting it down so I can stop the climb, get stabilized, and then continue on my way. And it was at this point that I was realized I had problems with the stick and that there was something wrong with the control system. And I thought, discretion, better part of valor. I got it stabilized here, and I'm just going to cut it off. And what you'll see in the next few frames is the the left elevon that's down. That kind of goes away, and you see the right elevon come a lot further down. So I am essentially over controlling because of the slop that's in the system. And when you see that right elevon come almost down, almost to full elevon, you'll see me release the tow line, and then I dip down lower all of a sudden and go to the left and set it down and end the flight. So, and then the next video I'll discuss why I came out of the sky so quickly at the end instead of having a nice smooth long glide.
The road broke. We were supposed to go to the left, but he's out of the way.
Here we have the side view of the same flight. We're going to run straight through on this view, and I'll come back with my analysis afterwards. Camera's mounted on the winglet mount, by the way.
Stop. Ready, Peter?
Ready.
Controls are free. Okay, go 35.
For this analysis of the side view for the flight, I've zoomed in much closer here, and we need to keep an eye on the position of the control stick, especially relative to elevator, and the control horn and the elevon. So the control horn and the elevon, top of the screen, control stick in the middle there, next to my knees.
Okay, go 35.
Okay, this is the segment where it's easiest to see what went wrong and how much hysteresis there is in the system. It's right after I released, and that makes it easy to see the problem because the extra loads from towing are off the glider. It's in gliding flight. So I'll put it in slow motion. You watch the stick and you watch the elevon or the control horn, and you'll see that sometimes there's some pretty large movements on the stick fore and aft elevator, and the control horn doesn't move at all. And that's the slack that's in the cables. And I've watched this many times and thought about this problem. It's like, how come I did not spot this problem before we started flying? I moved the controls around, and if there was slop in the system, I would have felt that, right? No. There's the weight of the elevons are pushing down, of course, and that pushes forward on both push rods, and that setup will cause most of the slack to be taken out of the cables. In other words, the weight of the elevons make it appear that there's always load on the cables, i.e. the cables are tight. And I can wiggle the stick around and not feel any hysteresis because of the weight of the elevons that are on there. Once I'm up and flying, the weight of the elevons is essentially negated by the airflow that's over the wing. And at that point, my brain is so busy trying to fly the glider, I'm not feeling that I'm moving the stick a lot and the elevons are doing nothing. And this is why it was great that the glider's stable to start with. Otherwise, I would have been all over the place. But this, I'll put it in slow motion. You'll be able to clearly see it. And of course, the obvious answer of solving the problem is a pre-flight check where somebody holds one of the elevons, or you lock in both elevons and try to move the stick. If both elevons are locked and you can still move the stick, you have a problem that you need to sort out. Pretty simple. Just got to remember to do it next time. Okay, here we go. Stick forward, elevon not going down. Pulling back, oh, it finally comes up. Pushing forward, the elevon's not going down. Pushing forward, still not really going down. Already down on the ground. But you see I've been moving the stick, and the elevon doesn't move that much. So in doubt, go back, take a look at it again for yourselves. But you'll see stick moves around a lot, elevon doesn't move so much. A lot of hysteresis makes the aircraft almost impossible to fly. Here we have the camera, a 360-degree view camera mounted on a pole aft of the pilot's cage, so you can get kind of a big bird's eye view of what it's like if you were riding right behind me. You'll see a lot of bouncing up and down like it's a really rough flight, but actually that's the stick that the camera's on, and the stick's flexing and the camera's bouncing up and down. That's all that is. So, and there isn't going to be any commentary on this because I don't believe there's much to see. Last segment I'll have more commentary.
Take up slack.
Taking up slack.
Stop.
Stop.
Ready, Peter?
Ready.
Controls are free. Okay, go 35.
Going 35.
And in this last segment, you'll see what caused even more problems at the end. Keep a close eye on my helmet relative to the backrest, and keep an eye on the shadow relative to my wheels. And you'll see that after I release, I'm worried about not being able to get the nose down, so I scooted forward in the seat a little bit, 2 or 3 inches, and all of a sudden it dives for the ground because the elevons finally kicked in, and I slid forward. So I got like double control input to go down, and I threatened the ground, and then at the last second I yanked the stick back and round out the bottom and make it look like a perfect flight with a gorgeous landing, but that was mostly luck.
Take up slack.
Taking up slack.
Stop.
Stop.
Ready, Peter?
Ready.
Controls are free. Okay, go 35.
Dawn 35.
Okay.
That. Okay, here we are looking at the mixer at the far end of the control stick system, and I wanted to show you this to talk about what we think went wrong out in the field last time. We had the glider fully assembled and did some taxi tests, and the wind got a little too strong, so we put it away for the day, and the wind never went back down. So we just took the wingtips off to prevent it from blowing away, and got it all secured and parked it for the night. Well, the wind during the night did 30 miles an hour and gusting, and what we believe happened is that this one of these 2 cables that has these turnbuckles on it was whipping around in the wind like this. 30-mile-an-hour wind will do that. And we have learned from previous trips that vibration of that type will cause the turnbuckle to completely undo itself. It will just unscrew itself and fall apart. So usually there's tape on it for transportation, and we should have had tape on it when we stored it so it couldn't move. But it didn't even dawn on me that the wind would be pushing this around the same way as transportation does. So we didn't do that. And then with the problems that I've been facing and other issues, and we were in a hurry to get going the next morning before it got windy, we didn't check the turnbuckles. And we believe one or both of them were slightly loose, causing slack in the cable, and hence causing slop in the control stick. In other words, as you reverse direction, you don't get control immediately until you take up the extra cable going both ways. And that can cause quite a hysteresis in the system, and then you don't have a good feel for control of the aircraft. Plus, when I got back home, I discovered, I have to get in close for this, I discovered that the bevel gears in the mixer, either some wear or tear, it's been there all along and I never really paid attention. Let me see if I can get this such that you'll be able to see it. The shaft that it's mounted on, steel tubing, but what really holds the alignment of the bevel gear is just nylon. That's a nylon gear over a steel tube, and it's not very precise, and it wobbles back and forth. They both do, front one and the rear one. Okay, and if these gears are not precisely tight together, as tight as they can be, you'll have slop in the system, which I do. Because when this is allowed to go back and forth like this, that opens the space in these teeth and causes slop in the system. And if you're sitting there on the ground, you can feel that slop, right? Sort of. But it's not overly apparent. And then there's this guy over here, this other bevel gear here. I have a, right here on the cap that secures the gear in place. There's a little popper of it here, and this slides on and holds this bevel gear up tight to the other bevel gears. And I do that with, I make sure it's tight because in here where you can't see is one of those wavy spring washers. So you compress this before you put the bolt in here, and that applies a force on the bevel gear to hold it tight to the other two bevel gears. But that doesn't work precisely if the other bevel gears are not tight to the shaft. And that spring washer may have taken some wear and tear over the years. So I'll have to replace that, and what I'm going to do is I'm going to put needle bearings inside all three bevel gears so that they sit tight with the shaft and there's no more slop in the system. And I think the real reason that it was a problem and not spotted, so I'm sitting in the cockpit over here. Let me walk you around here and we'll get a shot of the control stick. Oh, so you got to sit down for this one. I'm working in very tight spaces. So from the outside here, I'll do the same thing. So I'm in the cockpit holding the control stick like this. And how come I didn't spot that there's slop in the elevator? I don't have any slop in the aileron. It was all in the elevator. Ailerons are good, elevator bad. And how come I didn't spot that? Well, the ailerons themselves weigh about, well, 3.5 pounds or so, and they have a moment arm of at least 6 inches. So without the wind blowing over them, they have quite a bit of load in the system. And that load will take up the slack that's in the cable, and when I wiggle the stick, I won't necessarily feel any slop because of the weight that's on the elevons holding the system tight. Now, as soon as I get some airflow over the wing, well, that gravity that was holding the elevons down is now overcome by aerodynamics, and those elevons are running in the free stream behind the wing, and there's very little force on them at all. There's the same gravity that's there, but the aerodynamics are holding the elevons in place. So that allows the slop in the control system to then show itself. And what was happening is I'm a pretty good pilot. I know not to slam the stick around. So I would apply pressure, right? It's how we fly all the aircraft. We apply pressure, and we don't really think about moving the stick. We just apply forward pressure, back pressure, side, and so forth. And you fly it nice and gently that way. Well, if you apply pressure and nothing happens, well, you put a little more pressure on it. If nothing happens then you push on the stick. And that's what happens in control systems with bad feedback loops, hysteresis in the system. You end up, because you push forward on the stick and you're not going down, put a little more forward pressure on the stick, still not going down, nose is still coming up, and then you push on the stick because you've got to get the nose back down before you stall. So, and as it happened in this thing, and I'll talk about it in the video, is that I'm pressure on the stick, nose isn't going down, shove forward on the stick, nose whips down. Just at the same time, I'm deciding to shift my weight forward in case the CG is too far aft. So actually, as it turned out, I pushed the stick forward at the same time I shifted my weight, and wow, what a surprise! I was headed down to the ground really fast, and then so I just left my weight where it was, and I got back on the stick. I got it moved back far enough, and at that point I realized that I had a bad feedback loop, and I just eased back on the stick, but in a fairly large motion to flare it out for the landing, and everything worked out okay that way. I at least learned that shifting my weight forward, all I have to do is shift my hips forward maybe 3 inches, 4 inches, and you get a big nose down effect, which could be handy in other circumstances, you know, adjusting the CG in flight, especially if you wanted to have high-speed flight between thermals. And last but not least, the composite control stick and how it's set up. I think there's been some wear and tear on the composite parts, causing a little bit of slop. So the control stick really should be made of all metal and get rid of that problem. So I could build a whole new control stick system, or I can fiddle with this one a little bit until it's usable. You know, it won't last forever, but I can tighten things up enough, and I think it'll be fine on the next flight. We get all the slop out of the system, and we'll really be ready to fly. And once again, I have to say, thank God it's a really stable aircraft, because if it wasn't as stable as it is and you had this much slop in a control system, it could have ended up much differently with a lot of broken parts and broken hearts. So there we go. That's what went wrong, and lessons learned along the way. So I'm right here behind the camera, and I'm going to show you this change that I made to how I connect the control cables to make it a lot easier, less frustrating. So I had been doing this right here, which is a clevis type of arrangement like this, where one goes inside the other and then a pin goes through it. Standard clevis arrangement. And then the cables are connected to those little stainless steel connectors. And then a clevis pin goes through there and a safety pin on it. Perfectly safe, plenty strong enough, but boy, I tell you, really fiddly. You're out in the field trying to get these two halves put together, right? And you're like this, and you got the hole lined up, but now you need a third hand to put the pin in there. And that's a little tricky. And if you're slightly off on the alignment, the pin won't go through, of course. And then once you have that done, as long as there's a little tension on the cables, the clevis pin will stay in place, and you got to put the safety pin in. Well, I can't tell you how many clevis pins and safety pins I've had to replace that I've dropped once and they just disappear. Grass, sand, gravel, you name it, dry lake bed, they're gone. So I carry a bag of both of them to keep replacing it. And last time that we were out, I saw that my helpers at the time, Dan and Peter, were also struggling with this. And I thought, I'm just torturing my helpers and they'll never come back. So I need to come up with something better than this. So I had originally bought these because I thought I was going to apply them in a particular way, and I didn't. And I ended up, you know, they're $6, $7 each, so I thought, oh, I'll just use them somewhere else and make good use of that money that was spent. But it turned out to be very frustrating. So, and the interesting thing about problems like this is that once you find a solution like this, even though you don't like it, you sometimes get stuck with it because your brain gets in a particular rut and you can't think of a better alternative. And it can take some time. So what came about that caused me to change the situation was that we wanted to put yaw control system on the glider. And that would require new cables, new routing, new connectors, all of that. I thought, oh, here's my chance to come up with something better. So what I came up with is this. Now, it's a little bit far away. Let me bounce you over with the camera. You know, right like that. So what I have here is a standard thimble termination on the cable, much like this one right here, just a standard thimble. Cable goes around the thimble, and you got the Nyko press right here securing it. And that's all inside this red heat shrink tubing that's on here. And I thought, oh, shoot, that'd probably be the easiest connector in the world. I don't know why it dawned on me. It's like one of those little flashes. I can just use the smallest D-ring that I can find. It'll be plenty strong enough. You know, this will carry hundreds of pounds. So here you go. It's a secured link that you can unscrew very quickly in the field. And because of how these parts are arranged, you can get your hand in here, your fingers in here like this, and that stabilizes the whole thing. You're not going to lose the link, and you don't have to worry about this over there. It's just connected in, and all you have to do is just come in with this guy. It slips right in there. You let him hang there. Oop, you get back over there. That can happen. There we go. I got a better grip on it. And you just screw this closed. And there you go. Voila. You got your connection made. Perfectly secure, perfectly strong. No problem with that. So much easier than dealing with a clevis pin and a safety pin. And it has the plus of, at the root end, where the cables run close to each other, these safety pins can catch on each other. And I built little walls to keep them separated and stuff like that. But not a nice answer. This is much better. It's all rounded off, nothing to catch on. This can run right up against another one, and it's not a problem. Okay. So, did that. Then I found these. Bring this up close. It's a little tiny D-link, solid steel, and but quite small. So it's not too heavy. But I couldn't find any ratings for this. And it's just got a spring-loaded gate like this. Now I could use that here. I mean, this will go on the thimble just as easily. Click, you're connected. But I don't know how strong it is, so I just decided not to use them. I might use them on the yaw control, which is actually this guy right here. That's the new yaw control cable. And I might use them there. They're small, lightweight, and stay out of the way. And all of these are inexpensive. All of these links are quite cheap, just a few dollars each. Not a big deal. So, out with the less than satisfactory solution, in with the nice, neat and clean, inexpensive, not much heavier solution. Simpler is always better, of course. Got to follow that KISS principle. And in case you hadn't seen it before, I don't know if I showed it to anybody before, but what you're looking at here, this hump, let's see if I can get my hand up in frame. This hump right here, that is the yaw control cable, and it's running underneath a piece of mylar, and this surface on the wing, the nice slippery Oracal, and then there's a wide piece of duct tape over the top, so the tape can't stick to the cable, the control cable, yet it sticks to the wing, and that runs the whole length of the wing, and it's just a little tunnel for the yaw cable to run in, and really doesn't interrupt the aerodynamics very much. And besides, it's on the bottom of the wing, and you know the old saying, if you're going to mess up the aerodynamics, do it on the bottom of the wing, not on the top. So there, little, not exactly a quick tip, we'll just say that that's a medium length tip. And there we go. So now back to other parts of our program. Okay, as a closeout, first let me say thanks to Peter Hudson and Dan Armstrong. Dan's in the background there. Without them, these tests would not have been possible. They're stalwart. Love those guys. And I'm sitting in the cockpit, and they're just giving me a little pep talk to get me ready for the test flight at El Mirage, and we're discussing our plans for the flight. And I just thought it was a nice picture to end on. So at this point, the project is essentially on hold. I'll be puttering around in the garage as my energy limits allow. And I'll get the glider ready to fly again, but I don't know when we'll be able to take it back out again. That's a complete unknown at this point. I have high hopes for Stanford Long COVID Clinic. I am due to visit with those folks next week for the first time, and I hope they have some treatments that are helpful for me so that I can get back to work, because I believe the work that I'm doing here is beneficial to a lot of people, and not to mention fun. And I think that, and of course, my patrons, people on YouTube, all the support I've received is terrific, and I don't want to feel that I've let anybody on Patreon down by not actually finishing the job. They've all been very generous contributors to the project. But so I've turned off all the billing for everybody. I mentioned that before, and the sites will stay up. You can continue to look at stuff, and if there's a chance, we'll get this thing finished up. But I think there's going to be one more video coming where I discuss what knowledge has been gained for all of the efforts and money expended. and I think they're significant, and I think other people can make good use of them. So I thought it'd be worth spending the time to build a video that gathers up all of that information, and that'll give me a chance to run down the list of everybody that's helped on the project in some significant way, and give them credit where credit is due. And until then, I'll say to all of you what I always say: hang in there, fly safe, and bye for now.